Okay, C3, question 6, 6a. 4x3 minus EX minus 1 over 2x squared dx. I've got to bring this x2 up. So it's 4x3 minus EX minus a half x minus 2 dx. So you add 1 to the power, divide by it. The derivative is a 1 and it's in front, so it just goes back to e to the x. For this one, add 1 to the power, divide by it. Don't forget your c. Now tidy up. So 2 minuses, 1 over 2, x pops in the bottom, and don't forget your c. Part B, 1, 9, root x plus x over x squared add 5 dx. So to integrate the first, write it as a half. To integrate the second, we'll separate it out. I want to have the derivative of the bottom on the top. The derivative of this is 2x, so pop your 2 in and balance it outside. Now we are good to go. Add 1 to the fraction and divide by it. It's the same as turning it upside down. Half, you just log the bottom line and the top line disappears. 9 and 1. Putting in your 9, square root of 9 is 3. 3 cubed is 27. Divided by 3 is 18 times 9 times 2 is 18. Plus a half log. 9 squared is 81. Add 5. Take away 2/3 plus a half log 6. Now 18 minus 2/3 is 17 1/3 plus a half log 86 minus a half log 6. Tidying that or factorising out that half, you have got taken away 2 logs. If you take away 2 logs, that is the same as writing the numbers as a division. And that cancels down to give you log 43 over 3. Okay, the next one we're going to look at is 2018. It's the same paper, C3, and it's question 7b. So you've got your curve here and this shape going on. So y equals sec squared 2x, and this is pi over 6. Now let's do the area under the curve. Area under the curve is the area under the curve is the integral of sec squared 2x dx. Now where does sec squared come from? Well, tan goes to sec squared, so it'll go back to tan, but the derivative is 2, so I must have it in front, so balance it outside. That goes back to tan 2x. Your limits are pi over 6 and 0. Sub those in. So it's half tan 2 pi over 6, which is pi over 3, minus a half tan 0. Tan pi over 3 is root 3 and tan 0 is 0. Now, the required area is your area under the curve minus your rectangle. Now, your rectangle there is 1 times pi over 6. So your answer is 0.342. Okay, now the next one we're going to look at is 2018 C4 question 4 and question 8 of this paper. Okay, so I am wanting to have sec x. I'm trying to draw the graph between these values. So I always start off with a cos. So here's my cos graph to help me figure this out. At pi over 2 and 3 pi over 2, the cos graph equals 0. Because the sec graph is 1 over cos x, when it is 0, it shoots off to infinity. So if you get those asymptotes in there at the start. When this cos graph equals 1, 1 over 1 is 1, so it's here. And you reflect that up. When you are at pi and you're down at minus 1, so when you're at pi and you're down at minus 1, you've got the same point, but you shoot off to infinity at the asymptotes. And the same for the last point. 2 pi is at 1 and then it shoots off. Part 2. You want the volume and you're between x equals 2 and x equals 3. So the volume is pi sec squared x, you can just put that instead of putting y in, and you're between 2 and 3. Now where does sec squared comes from? Well, tan goes to sec squared. There's no derivative to worry about, so it will just go back to tan x, 3, 2. Sub in your 3, sub in your 2. And if you put that through your calculator, you should get 6.42 units squared. And we have one more to do out of that paper, question 8. It's quite a long one. So, question 8. And it's starting off, part A, x cot squared x dx. Now, if you want to start off using integration by parts, you would naturally go u equals x, dv by dx is cot squared. Then when you think of all your tan rules, nothing gives you cot squared, so you're stuck. So you've got to think of something else. Now, cot squared is linked to cosec squared using this wee formula. And cosec squared works for your differentiation and integration. So what I'm going to do is I'm going to take this here expansion, or this here integral, and I'm going to write it as cosec squared minus 1 dx. Now, multiplying that out is x cosec squared minus x dx. I'm going to split that up. X cosec squared x dx minus x dx. I'm going to use integration by parts here. U is x, dv by dx is cosec squared x. Differentiating this, you get 1. Now, cosec squared, where does it come from? Well, cot goes to minus cosec squared. So what I'm going to do is I'm going to integrate this back, but I must have a minus in front, and it will go back to cot x. And I've still got that minus outside the integral sign. So it's quite tricky there. So what I'm going to do now is I'm going to use my uv minus v du by dx for this bit. And then this bit's just going to be ordinary. So it's quite a lot to keep your eye on here. U, v, minus v, du by dx is a 1, dx, minus integrating this, x squared over 2. Tidying this up, minus x cot x, and if you, I have a minus in here, so it's the v is in here, that becomes a plus cot x dx because it wasn't balancing, it was just a minus in there. Now, how do you integrate a cot? Cot is cos over sine. So, integrating a fraction, do you have the derivative of the bottom on the top? You do indeed, because sine goes to cos. So you just log the bottom line. And that's part A done. Part B, part 1. You're asked to write this in partial fractions. So this isn't too bad. So it's a over x plus b over 2x minus 1. Do the tops. So this one needs an extra 2x minus 1. And this one needs an extra x. Choose x to be a half to get rid of that there bracket. So you have 2 equals that's gone. A half b. So b is 4. And then choose x to be 0. So you get 2 equals, if x is 0, it's minus a, and that disappears. So a is minus 2. So you're going to rewrite your expression as a, which is minus 2 over x, plus b, which is 4 over 2x minus 1. Now, on to part 2. The integral is 1 to 9, and you're told to use x equals u squared. And you have 1 over x, 2 root x minus 1 dx equals 2 log a over b. So let's deal with this x first. So x is u squared. So differentiating it, power goes to front and take 1 off. Rearrange that. So it's 2u du. Now, I'm going to take that and put it into my integral sign. So my integral sign is x equals 1, x equals 9, 1 over x is u squared. 2 root x is u minus 1. dx is 2u du. Now what does that tidy up to give me? X equals 1, x equals 9. So I've got a 2u over u squared, gives me a u in the bottom row, du. Now my integral signs are wrong here. I've got x's. So an x is u squared. So when x is 9, u is going to be 3. So that's the top one, u equals 3. And when x is 1 for the bottom integral, u is going to be 1. So u equals 1. Now if you notice, this here is identical to what you've done in part A. So you're going to write this as minus 2 over u plus 4 over 2u minus 1 du. Now to integrate that, I'm going to just tidy it up first. So minus 2 outside, and it's 1 over u du, plus I'm going to bring that 4 outside and leave me 1 2u minus 1. Do I have the derivative of the bottom and the top? I do indeed, so I can just log the bottom. On this one, do I have the derivative on top? No, it's a 2. So put your 2 up and balance it outside, so it becomes 2. Now you can log the bottom line, and I've got limits to put in, 3 and 1. So I'm putting in 3 first of all, so it's minus 2 log 3 plus 2 log 5. Now putting in 1, so it's minus, so what's the minus signs there? Minus 2 log 1 plus 2 log 1. Log 1's disappear, giving you 2 log 5 minus log 3. You can factor out the 2. You're taking away 2 logs, so you can divide the numbers.